Start.
Hello, one and all. This is Gautam from NIT Andhra Pradesh, pursuing my bachelor's in mechanical engineering. Today, I will be covering the topic electrostatics, which is a very main fundamental topic for the JE mains and advanced. In this session, I will be covering the concept of electric charge, electrification and its types, and the basic properties of charge. Let us start the discussion of the topic. Electrostatics. Electrostatics is nothing but the study of the charges at rest. What is a charge? A charge is a fundamental property by virtue of which the magnetic and electric effects are seen. Say in a body, if the number of electrons in a body is more, then it is said to be a negatively charged body. And if a body is said to be positively charged if the number of electrons are less than the ideal or neutral body. Simply, excess of electrons in a body is called negatively charged body, and the deficiency of electrons in a body is said positively charged body. As in a negatively charged body, there are additional electrons in it, so the overall mass of the negatively charged body will be increasing. Similarly, in a positively charged body, the number of electrons are less in number, so the overall mass will be decreasing. A charge is a scalar quantity. The SI unit of a charge is coulomb, and one electrostatic unit of charge is equals to some 1 by 3 into 10 to the power of 9 coulombs. Similarly, one electromagnetic unit of charge is approximately 10 coulomb. We will discuss the concept of electrification. In very, very simple words, electrification is nothing but the process of giving charge to a body. It is a process of giving charge to a body. How can we give charge to a body? There are three basic methods in which we can give charge to a body. These three methods are known as methods of electrification or types of electrification. They are namely friction method, conduction method, and induction method. Let us see the each type of electrification process one by one. Friction method. If two bodies are rubbed against each other due to the frictional force, there will be the transfer of electrons taking place from one body to the other body. In this way, we can charge a body. Say for best examples for this are take a glass rod and some silk cloth. Rub the glass rod with the silk cloth. The glass rod will get positively charged and the silk cloth will get negatively charged. Similar to this, if we take a ebonite rod and rub with fur, the ebonite rod will get negatively charged and the fur will get positively charged. Now, let us see the second method of electrification, that is the conduction method. If a charged body, if a charged body is kept in contact with an uncharged body, this is a charged body and this is an uncharged body. If we keep a charged body in contact with the uncharged body, then due to this contact, the charge will get transferred. Say, if it is a positively charged body, it was electron deficient in nature. When this body comes in contact with a uncharged or a neutral body, it will take the electrons out from this neutral body and make this body charged. Similarly, if it is a negatively charged body and comes in contact with a uncharged or neutral body, this charged body will give off its electrons or excessive electrons to the neutral body, making or trying to attain the neutrality. In this way, it is becoming charged. This is the conduction method. Say, if we consider an example of two identical metal spheres, if we see two identical metal spheres of charge q1 and q2, then the net charge q is given by q1 plus q2 by 2. This means the total charge is equally shared with the in during the conduction. And coming to the next method, that is the induction method. When a charged body, this is a charged body, is kept in near to the uncharged body, the charged body, say it is a positively charged body, this positively charged body attracts the negatively charged bodies in the neutral body. Say this is a positively charged body and this is a neutral body. This positively charged body attracts the negative ions, that is electrons in the neutral body, to the uh, nearer end, and it repels the positive or like charges, as you can see in the figure 1. Now, this neutral body is earthed to the ground with the help of a wire. The excess or deficient of charge will be compensated through grounding. And after that, if we remove the grounding, then the charge which was there, that is negative charge over here, was attracting to the positive charge in this manner. If we remove the positively charged body as well as, then we can get a uniformly distributed charged body, as you can see in the figure 4. This is done through the method of induction. Coming to the thing, how much is the induced charge? If we say the magnitude of the induced charge is depending on the material of the body. This what defines this material of the body? It's the dielectric constant. So let us consider Q as the induced charge and q as the inducing charge and q dash as the induced charge. Then q dash is given by minus q of 1 minus 1 by k. This is the equation. Now let us see the basic properties of charge. The first and foremost basic properties of charge is additivity. In case of the given system, we are having the four charges, plus q1, minus q2, minus q4, and plus q3. The charges always add. That is, q is equals to q1 minus q2 plus q3 minus q4 and so on. Suppose we are having some n number of charges in a system, then the value of the net charge is q1 plus q2 plus q3 plus and so on plus qn is the total charge. And coming to the next property of charge is the conservation of charge. Conservation of the charge is nothing but the sum of the charges is constant. We can come to this conclusion by seeing the thing that a charge can either be created nor destroyed. Thus, the sum of charges remains constant. That is, q plus q minus is always remains constant. That is, net charge will always remains constant. Sum of the charges. Coming to the next property, that is the quantization of charge. Quantization of charge is nothing but the electronic charge is multiplied by a the electronic charge is multiplied by a factor n, that is number of electrons, then we will get the net charge. Say the electronic charge, that is the value of E is 1.6 into 10 to the power of minus 19 coulombs. And coming to the next one is the charge is invariant in nature. And coming to the fifth property, that is like charges repel each other, and unlike charges attract each other. Now let us see a question. How many electrons present in 1 coulomb of charge? Say we are having a net charge of 1 coulomb. Now the number of electrons we should find. I had given a formula that Q is equals to Ne. Therefore, number of electrons is equals to Q by E. That is, Q is 1 coulomb in here, and the charge, electronic charge, is nothing but 1.6 into 10 to the power of minus 19 coulombs. Then we will get a value of 6.25 into 10 to the power of 18 electrons in this particular thing. We have successfully covered the concepts in this particular session we are intended to do so. That is the electric charge, electrification and its properties, and the basics of properties of the charge. Uh, a brief summary: the electrostatics is nothing but the study of charges at rest. An electric charge um, is a thing by virtue of which electric and magnetic effects are created. And coming to the electrification, it is the process of giving charge to a body. In that, we are having three types of electrification, that is conduction method, friction method, and induction method. And basic properties of the charge, that are additivity, next invariance, um, what is that? Sum of charges is remains constant, and also the remaining. Thank you for listening.